Hi, I'm Larry Puckett, the DCC Guy. You know, a couple of years ago in 2019, when I first started making a lot of videos for the YouTube channel, I started off with a series on control panels. And in that series of videos, I showed how I basically create the control panels for the Piedmont Southern and how I wire them up to control the Tortoise switch machines here on the layout that activate the turnouts. Now, I actually have two different ways of controlling these turnouts. Now, on most of the control panels here on the layout, I use push buttons. And the reason I use push buttons is because I have them combined with NCE switch 8 accessory decoders and button boards. And those will take input from a simple push button to activate the Tortoise switch machine. However, back when I first started on this, I wanted to do an article for Model Railroader for my DCC corner column on how to use DC power to control turnouts. And so that's why I went ahead and started using them here in this section of the Piedmont Southern. And you'll notice the main difference is here I'm using toggle switches instead of push buttons. So basically, I can throw the toggle switch and it will control the direction of the turnout itself. In addition, if you can notice here, the red LED is lit. That indicates that this path or route is thrown. Whereas if I throw it the other way, you'll notice it's gone back to green. So the fact that the light's on indicates which route the train will take, and the color, green and red, indicate the normal position, which is green, and the thrown position, which is red. So what I want to show you today is how I go about wiring these toggle switches to control my turnouts using DC power. Or actually, what I'm going to show you is how to use AC power to make DC power and then to control the turnouts. So let's go back to the workbench where I've got everything set up, and we'll take a look at how you go about doing that. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. Thanks now. Well, let's go ahead and get started. What I have here is the instruction sheet that comes with your Tortoise switch machines. And on the second page of this instruction sheet, they show three different methods for wiring and providing power to a Tortoise switch machine like this one here. And the first method uses a DC power supply and double pole, double throw switches to route the correct polarity of power to your Tortoise switch machine. Now, this is a very straightforward, easy method to set up. However, it does require you to wire in and solder a reversing circuit on the double pole, double throw switch. And that creates a lot more wiring headaches. It also requires that you buy DPDT switches, which I think you'll find are a little more expensive. Now, the second method uses something that sounds like it's going to short out. And that involves using two DC power supplies, connecting one set of plus and minus terminals together to create a bus wire for one terminal, and then use the other plus and minus outputs to route through the single pole double throw switch and then feed the other terminal. So by simply throwing the single pole double throw switch, you change the polarity of power being fed to the other terminal, and that will automatically reverse the direction of travel. I don't like this because, you know, of the need to hook up two DC power supplies. And I can just see problems for people who are not used to wiring and working with power supplies like this when you start wiring these together. Finally, the third approach is to use an AC power supply and then use a pair of diodes. Now, I use 1N4001 power diodes. They're 1 amp diodes. So you can run maybe 50 Tortoise switch machines off of 1 amp. So it's not a limitation at all. And the way you do this is you just hook these up together in opposite orientation. And then that will give you what's called half-wave rectified DC power. So if you start out with about 16 volts out of your AC power supply, you're only going to get about 8 volts out of the positive and negative sides here of this rectifier. And it's a fairly, after that, it's fairly straightforward, very similar to this approach. You just run the positive and negative feeds into the single pole double throw switch, and the output from that then goes to your Tortoise switch machine. So that's fairly easy to set up. This is the method I use on the Piedmont Southern. For one thing, the single pole double throw switches are smaller. You can more easily fit them into a control panel. They're also cheaper than a double pole double throw, and they don't require all that double amount of wiring and reverse wiring going on. Now, the other thing that you can do that they show you here is to hook up two LEDs in opposite orientation so that you can get an indication of red or green, for example, to go along with the movement of the Tortoise switch machine. So let's go ahead and take a look at how I set up this whole circuit. Now, I start with a standard old AC adapter. If you don't have one laying around the house, you can probably pick one up in the trash bin at work sometimes. I know I've got a whole box full of these that I have collected over the years from various power supply situations. And this particular one is rated at 16 volts AC and 1.1 amp, which is going to work out fine with these 1 amp 14001 diodes that I'm using here. And 16 volts is going to give you about 8 volts to operate your switch machine, your Tortoise switch machine. So that's a fairly easy thing to come up with. If you don't have one of these, you can get these from companies like allelectronics.com. There we go. Okay, let's take a look at the rest of this circuit. So then, I'm going to disconnect that. I just took the end of that cord coming out of the AC power supply, cut the barrel plug connector off, and stripped the wires here. So that gives me an AC power supply right there. Now, the rest of this. Now, right here are the two diodes that I use in this circuit. They're both 1N4001 diodes, and you'll see then that there's a white or silver band at one end or the other of the diode. Now, in this one, it's at this end, and at this one, it's at this end. Now, that indicates that they're of opposite polarity, so they're only going to pass electrons in one direction. So right here, this one is going to give you a positive polarity. This one here is a negative polarity. And I checked that with a simple voltmeter and hooked it up to the two wires here, or to the two outlets from the diodes, and then just noted whether I was getting negative or positive indicators on the voltmeter itself when I checked the DC voltage. Now for this, I've just soldered the two leads from these together here at this end. And that's going to allow me to feed my AC power into it. So I'm going to take my a red clip lead and connect it here. And then I'm going to take the other end of that clip lead and connect it to the AC power supply. Now let's look at the rest of this circuit. Okay, so we're going to get positive and negative polarity from this. And that I'm feeding into this single pole double throw switch. So I've connected the red and the black wires to the outside poles on the single pole double throw switch. And what happens is, depending on which direction that this toggle is thrown, one or the other of these wires is going to be fed through to this white wire in the center. So then I take the output from the single pole double throw switch and run it through this white wire. Then the next thing we've got here are two LEDs. Now, light emitting diodes are diodes just like those others I just showed you. So they are polarized. They have a plus and a negative orientation. And the way you can tell is one leg is longer than the other. So all I did was took a long leg and a short leg, wrapped them together and soldered them. And the same thing here, a long leg and a short leg, wrapped them together, soldered them, connected them to this white wire here, and this white wire that goes to one terminal here on my Tortoise switch machine. So depending on which way that this is thrown, it's going to provide either positive or negative power to my Tortoise switch machine, and only one of these LEDs is going to light up, depending on the polarity running through here. We'll show you that in a minute, okay? Now, the other thing I've got is a black wire. The black wire I'm connecting to the second lead on the AC power supply, and then that runs to the other terminal here for the motor control here, the motor power on the Tortoise switch machine. So that acts as just one leg of the circuit directly from the AC here. So that acts as a common, if you will, that the positive or negative can be connected to complete the circuit. So now let's see how this works. So I've got everything hooked up, wired up. I've got the power supply turned on. So all I have to do is throw this switch. The Tortoise switch machine has thrown, and you'll notice we now have a green LED. Now if I throw it back the other way, it reverses polarity. The turnout throws the other direction, and the red LED is on. And this is exactly the way that I wired the toggles and the LEDs on the control panel that I showed you at the beginning of the video. But how do you know which way the Tortoise switch machine is going to throw when you throw that switch? Well, you don't, unless you've figured all this stuff out in advance. It's easier in the long run just to go through the steps, set it up, you know what's plus and minus here, and run your wire into these guys. Now at this point, instead of soldering these together, you can take a couple of clip leads like these, and I buy these in bundles because All Electronics sells these fairly inexpensively. It's under $10 for a bundle half of this size, and I've got a couple of them here. These are great for making quick connections under your layout to test anything. You can test a connection before you hook it up permanently using these guys. And again, allelectronics.com. I just have tons of these around here. They come in different lengths. I have the long ones and the short ones. And as I said, they're great for making quick connections and testing circuits in advance. So one thing you could do is just, after you've hooked up your two LEDs in opposite orientation, just hook your clip leads up here to your wires and the output to your switch machine, and you can find out very quickly which way it's going to throw given a certain orientation. And then you can, if you don't like that combination, you can just flip it, make different connections. You can reverse the connection here and find out which way that's going to throw. Because you might want the red LED to light up when the turnout is thrown one way, and the green to light up when it's thrown the other way, and then another one right next to it, you might want it to do the reverse of that. And figuring that out in advance is a little bit more complicated than just taking a couple of clip leads and testing it and finding out, and then reversing the connections before you make the final connection to your circuit. So that's all there is to it. It's very straightforward, easy circuit to work with, and I suggest that do what I've done here. Take the various parts that I've shown you how to hook up together here, and I'll put a parts list in the description to the video of everything that I've used here. And most of this stuff, I got these from All Electronics. I got the diodes from All Electronics. I got the LEDs from All Electronics. The clip leads are from All Electronics. All the wires are from All Electronics. This is not an ad for All Electronics. They haven't paid me to say this, but I just buy a lot of stuff from them because they have it and it's quick and easy to order from them. They ship fairly quickly. So go ahead, pick up some of these materials if you want to try this out, and get up, set up on your workbench somewhere, or a desk or whatever, the kitchen table if your wife will let you, and hook all these things up using clip leads or quick solders, whatever you want to do, and see how this works. And once you get a feel for exactly how it goes together, you will be able to, in advance, know that if you have plus minus here and a common wire going to these two guys, that they're going to turn red or green depending on whether it's positive or negative. It's fairly simple to figure that out in advance. Now let me give you a quick tip about the LEDs. I told you that one leg was longer than the other. On LEDs, the long leg is positive, the short leg is negative. So that's all you have to remember. Long leg is positive, short leg is negative. When you connect them together, you just want to hook a long and a short together on this side, a long and a short together on this side, and depending on which long or short you've got and the polarity of the wire that they're being fed, one of them will light up, but not both of them. And I will tell you, you don't need a dropping resistor for this at all, because most of these LEDs will operate with about 20 milliamps, and that's all that a Tortoise switch machine pulls, 20 milliamps. So you feed 20 milliamps through here and to your switch machine, everything's going to be fine without a dropping resistor to control it. Well, that's a wrap for today's video. It's a fairly straightforward procedure to go ahead and wire your control panels to control your turnouts using the diode routing process that I showed you in this video. So the next time you're getting ready to set up your Tortoise or other switch machine type turnouts, give this method a try. I find it a lot easier to use than some of the other methods that Circuitron suggest in their instructions for wiring their Tortoise switch machines. So have a great weekend, and we'll see you here next week with some more videos from the DCC Guide. Bye now.